Alright, so on this video we'll be talking about trapezoids and kites and how to use their properties to solve problems. So first of all, what is a trapezoid? A trapezoid is a quadrilateral that has two parallel bases and two non-parallel legs and two pairs of base angles. And so your base angles are these angles here on the bottom, but then up on top, another pair of base angles is also these two angles, are also considered base angles. The mid-segment of a trapezoid is the segment that connects the midpoints. So this would be a midpoint and this would be a midpoint, which means those two sections are congruent and those two sections are congruent. And finally, an isosceles trapezoid is a trapezoid that has congruent legs and the base angles are congruent. So these two would be congruent to each other, and then the top base angles would be congruent. Now, the two bases are parallel, so essentially I have parallel lines being cut by a transversal. And so these angles on the side here, the top base angle and the bottom base angle, are consecutive interior, so they're going to be supplementary. In other words, they add up to 180. Alright, so for example, one, we are going to show that CDEF is a trapezoid. So in order to do that, I need to show that I have two sides that are parallel. And I have to show that I have two sides that are not parallel. So the easiest way to tell whether or not lines on a graph are parallel is to look at their slopes. So first I would look at the slope of DE and the slope of CF. So the slope of DE, I'm going up 1 over 3. So my rise is 1 and my run is 3. And then if we look at CF, I'm going up 2 over 6, which also reduces to 1/3. So that means that because they have the same slope, I know that DE is parallel to CF. So I've shown that two sides are parallel. Now I'm going to show that the other two sides are not parallel. So I'm going to look at the slope of CD and the slope of EF. So looking at CD, I'm going up 3 over 1. So the slope there is 3 over 1, or 3. And if I look at EF, that one's actually going down 2 and over 2, so negative 2 over 2, which is negative 1. So the slopes are not equal. And that means that CD is not parallel to EF. And because of both these things, then I can say, therefore, CDEF is a trapezoid. Alright, so we're going to look at some properties that are true for isosceles trapezoids. It's important that they are isosceles. This is not going to be true of any trapezoid, just isosceles trapezoids. So for isosceles trapezoids, each pair of base angles is congruent. So angle A is congruent to angle D, and angle B is congruent to angle C. Another thing that's true for isosceles trapezoids is that the diagonals are congruent also. So in my figure, AC is congruent to BD. Now it's important to realize this is not like a parallelogram. The diagonals do not bisect each other. So make a little note of that. The diagonals do not bisect each other. Which, if you look at them, it's pretty clear that they're not being cut exactly in half. All right. When you have the mid-segment of any trapezoid, so now we're not talking about isosceles, we're talking about any trapezoid. The mid-segment is going to be parallel to the two bases. So that means that those three lines are parallel. AB is parallel to MN and parallel to CD. And the length is half the sum of the lengths of the bases. So the length MN is going to equal 1/2 of AB plus CD. Earlier in the year, we talked about area for a trapezoid. So you may recall the area of a trapezoid. The formula for that was 1/2 the height times base 1 plus base 2. Well, if you look at that formula, half of base 1 plus base 2 is the same as the midsegment. So another way that you can find the area of a trapezoid is it's actually going to equal the midsegment times the height. All right, so looking at this example, we're going to find the measure of angle N, the measure of angle L, and the measure of angle M. Well, I can see that it's isosceles because these two sides are congruent. So that means that the base angles are congruent. So the base angles of an isosceles trapezoid are congruent. So the measure of angle N is going to have to equal 50 degrees because these two are congruent. And then I know the top two are congruent to each other. And because these add up to 180, I know the measure of angle L and the measure of angle M has to equal 180 minus 50 or 130 degrees. So that would be your answer for that one. Next we have an example with a midsegment. Here we're going to find the length of MN. So you'll recall the formula. My midsegment is going to equal half of base 1 plus base 2. So in this case, MN is my midsegment. It's going to equal half of 16 plus 9, which is half of 25. So that means that MN would be 12.5 inches. Now sometimes you may have a problem that instead of giving you numbers, they give you expressions. But we're still going to do it the same way. We're going to plug in what we know and solve for what we don't know. So again, the mid-segment is equal to half of base 1 plus base 2. So my mid-segment in this figure is 4x, and that has to equal half of 7x minus 6 plus 2x plus 3. So now it's just an algebra problem, and we can go ahead and combine our like terms there in our parentheses. If we do that, 7x and 2x is 9x, and negative 6 plus 3 is minus 3. So since I don't have even numbers inside my parentheses, I'm going to go ahead and multiply both sides times 2 so that I don't have to deal with the fractions. Of course you can, or you can make it a decimal. You'll still get the right answer, but I know a lot of you don't like fractions, so we'll go ahead and get rid of them. Alright, so now I have 8x is equal to 9x minus 3, because over here those cancel out, and so x would equal 3. Alright, now we're going to talk about kites. A kite is also a quadrilateral, but with a kite you have two pairs of consecutive congruent sides. So instead of opposite sides being congruent, the consecutive sides are congruent. So those two would be congruent and these two would be congruent to each other. So it's important to remember the opposite sides are not parallel on a kite. It turns out whenever you have a kite, the diagonals are perpendicular. So we're going to be making some right triangles. Undoubtedly we'll have some problems with the Pythagorean theorem. So in this figure, AC is perpendicular to BD. And another thing that's true for kites is that exactly one pair of opposite angles are congruent. And it's the pair of angles that are between the non-congruent sides. Okay? The congruent angles are between the non-congruent sides. And again, if you look at the figure, it's pretty clear that angle B and angle D are not congruent to each other. So you shouldn't have a hard time figuring out which ones are the congruent ones. So I know that angle A is congruent to angle C, and angle B is not congruent to angle D. So we can use these properties to solve some problems. We're going to find the measure of angle T in the kite. So I know that angle T and angle R are congruent to each other. So if I just let them each be x, a quadrilateral's interior angles have to add up to 360. So 70 plus 88 plus my two x's have to equal 360. And then if we add the 88 and 70, we get 158. So 158 plus 2x equals 360. If I subtract 158 from both sides, I get that 2x is equal to 202. And so dividing by 2, x is equal to 101 degrees. Alright, so we've got another example here. We're going to find the value of x and y. So as I mentioned before, when we have a kite, the diagonals are perpendicular, which means I have some right triangles. So if I look at this side over here, I've got a 3, 4, so that is a 3, 4, 5 triangle, so I know x is going to equal 5. And then looking at this other triangle on the other side, to find y, that one's not one of my Pythagorean triples, so I'm going to go ahead and have to use the Pythagorean theorem on that one. So 4 squared plus 10 squared is going to equal y squared. 4 squared is 16, 10 squared is 100, that equals y squared. So y squared is going to equal 116, and I take the square root of both sides, and so y is going to equal, well, first of all, 116, 4 does go into it, so we'd have 4 times 29 to get 116, and so y would equal 2 root 29. And if you put that in your calculator, it would be approximately 10.8. So just depending on what the problem asks for, if they want you to give it in simplest radical form or as a decimal, you can answer it whichever way it says. So x would be 5 and y would be 2 root 29 or 10.8. And that concludes this video. Thank you.